Hello everyone, I am Berk Ali Çam and I study at Dokuz University, Mechanical Engineering Department. And today I would like to talk about our project, Design and Implementation of a Remote Control System for an Unmanned Underwater Vehicle. First off, I want to briefly explain what unmanned underwater vehicles are. They can be classified into two main groups, which are ROVs, Remote Operating Vehicles, and AUVs, Autonomous Underwater Vehicles. ROV, in its most general definition, is an underwater robot that can be controlled remotely by an operator and performs several functions underwater. And next up, this is the setup shown here. This part is basically a robot, and its main components are Raspberry Pi, Arduino Mega, camera, IMU sensor, ping sonar x2, 4 thrusters and their ESCs to control them, and lastly, battery and the power distribution board. And this here is the operator side. This is the operator human-machine interface. In our case, it's a joystick. And lastly, PC, which uses Ubuntu and ROS. ROS is Robot Operating System, which is actually a framework that allows us to do robot applications with ease. Robot and PC is connected via master-slave connection, which enables the data transfer between the Raspberry Pi and the PC, and it also allows us to run the commands on Raspberry Pi by typing them on PC. The main working principle behind the system is when the operator uses the joystick data is transferred to PC, then to Raspberry Pi, and lastly to the Arduino Mega. And here, this joystick data is turned into PWM signals, which is then used to run the thrusters. And the whole system is powered with a battery, and this battery is connected to the power distribution board, which distributes the power to the ESCs and to the Raspberry Pi. Besides remote controlling with a joystick, we also have 3 sensors here, which I will be explaining later. And this is the image of our system. Here on the operator console, we can view the data that we receive from the robot. And with this joystick, we move the robot. And here is the rotor, battery, power distribution module, and the thrusters. And we fit those in these tubes. And now I will be explaining the remote controlling. Our robot can go in 6 directions: forward and backward, left and right, upward and downward. All these moves are controlled by these 2 analogs, and these analogs have their own axis. These axis values differs between -1 and 1. When the analog is fully pushed, this value reaches to 1, and when it's released, it is at 0. This way, we can both control the direction and the speed of the robot. In this process, we use the package called join_node. Join_node allows us to see which of the analogs have been moved and how far and in which direction we moved them. For example, axis 0 corresponds to moving the left analog upward and downward. If we move the analog upward, axis 0 value will be greater than 0. And this value then will be read from the Arduino board and will be turned into PWM signals. Then this signal is transferred to ESCs, and the thruster or thrusters that are responsible for moving forward will be run. Next, I'd like to talk about the sensors that we used in our project. First, we have Raspberry Pi camera. This camera allows us to survey the area which the robot is working or moving. Captured videos from the camera can be displayed on the operator console in real time using a ROS package called Raspicam. Secondly, we have ping sonar. We used 2 sonars in total in our project. They are both planted on the same side, and they are responsible of the robot moving in parallel to a straight surface. If sonar values are not equal, it is detected in the Arduino code and adjustments are made by moving the robot right or left. Last but not the least, we have inertial measurement unit. It for now only displays the yaw, pitch, and roll degrees, and also 3D acceleration data. And lastly, I'd like to summarize what we did in this project and tell about our future goals. In this project, we made observations using real-time sonar data and real-time video stream taken from RAW, besides real-time velocity and 3D acceleration data from the IMU sensor were presented on the operator console. Our goals for the development of this prototype is implementing more professional thrusters to the system, thus increasing the maneuverability and increasing the range capacity of the underwater robot using higher capacity batteries and providing autonomous features to the experimental underwater robot. And that concludes my presentation. Thank you for listening.